I'm just trying to explain things civilly, okay? I mean, sometimes I freak out and I start talking like a werewolf. You know what I mean? But all we're trying to say, is that light isn't jello. Okay? Light is not a block of jello. It's not a block of jello in stasis where all the stars and galaxies in my universe exist within it, and light always goes the same speed relative to everything within it. So that no matter what, no matter how fast anything's going, light has to slow down, for it. You know what I mean? So, like, light doesn't have a variable speed, is why Einstein used it for E equals mc squared. The constant, because light has no variable speed. And so, because light has no variable speed, I can anything that is emitting light is still moving at a speed in the universe. But that light has a point of origination at its emitter. You know what I mean? So if my emitter is moving like, 186,000 miles an hour, or miles per second, if my emitter is moving 186,000 miles per second, and then it emits a photon, that photon will go 186,000 miles per second from the emitter, no matter how fast the emitter was going. But the emitter itself, it must be comparing its speed to something, so we'll call that M1 or M0. That's the mother point of that emitter's that's the mother point of this emitter's origination. So where it started, where it considered itself going zero. So then from there it went 186,000 miles per second. When it emitted the light, that light was considered this as its M1, its point of origination. And so the light is only going 186,000 miles per hour from its point of origination. But what I was trying to say with the principle of cumulative acceleration is to use relativity to actually travel faster than light. And we simply do that by counting from the mother point of origination, drawing a whole line and adding them up. So I'm going 372,000 miles per second. This photon is going 372,000 miles per second. Relative to these people who care about that. They care about that. Okay? So in order to take that and put it into a formula where I can use it, that's where I got the P equals C over X equation. Where is it? where is it? Where's my flashlight? That's where I got the P, that's where I made the P equals C over X equation. Okay? P equals C over X. Now, each pulse, I'll show you. This is P1. This is P2. Right? So, the pulse that got me to 186,000 miles an hour from M0 is P1. The pulse that got me another 186,000 miles a second from M1, that is called P2. Right? So, the top number in my P equals C over X equation can be any number, but I usually just use C to make it easy. But say, so for in this example, I'm trying to go 2C, or 372,000 miles per second, because that's what I've drawn, right? So, I have, you know, so X is the thrust. So X is 186,000 miles per second. And the top number is 2C. So in order to go 2C, if my thrust is 186,000 miles per second, it takes me two different pulses. And what that means is each pulse is a new point of origination. But I can count those and put them on an entire line. So like say, you know, say I want to go a certain specific speed. You know, I put that into the top to figure out the number of pulses to go that speed. I put it in the top. So I want to go light speed. And my thrust of my rocket is this much. So this is light speed, this line, 186,000 miles per second from my M0. Okay, so from my mother point of origin, I want to travel 186,000 miles per second. And the thrust of my rocket is 6,000 miles per second. Okay? So X equals 6,000 miles per second. Now, that means that 6 into 186,000, or 6 into 186 is 31. So I need to do 31 pulses. 31 different pulses on my line. Because P for the equation equals 31. So here I fire my rocket, 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 I fire my rocket. And I divide the line up like that. 31 different line segments now. Right? Now, at the beginning of each line segment, I'm going match velocity relative to my own rocket before I accelerate again. So I'm going relative 0, and that makes me allowed to accelerate every time at the same speed. Understand? So at the mother point of origin, I accelerate and I go 6,000 miles per second. Then at M1, I accelerate. No, at M1, my speed, here's the thing. Oh man. Here's the thing. At M1, my speed is 6,000 miles per second from the mother point of origin. But because I'm going match velocity relative to myself, my speed is 0. Right? So at M1, I hit my thrusters again. 6,000 miles per second. Now I'm going 12,000 miles per second on this line segment. On the line segment that takes me from M2 back to M0, I'm going 12,000 miles per second. So on the line segment that takes me to M3, I'll be going 18,000 miles per second, M4, 24,000 miles per second, and so on. But at each M, my vessel is only required to go my vessel only does and only is required to accelerate 6,000 miles per hour. 6,000 miles per second. See what I mean? So it accumulates over time, and my speed adds up from my mother point of origin. But because my 0 point of origin, after we're going match velocity, when I accelerate again, because that is carried with me throughout my journey, then I can continue to do it and go faster and faster and faster and faster and faster. And that's how I can go over the speed of light. Like, this is the same concept, like, why don't you die when you fall down? If the sun is going so fast through the galaxy, and the galaxy is going so fast through the universe, and the earth is going so fast around the sun, then all this should add up behind you. And when you fall down, you should be hitting the ground at multiples of the speed of light and dying instantly, disintegrating, at just the slightest touch of anything. But it's because you're going match velocity, so that's your 0 point of origination. So that's how it works, and that's how you can go faster than the speed of light. You just have to add it up. I understand what you mean when you say, dude, there's no way you can ever do a continual thrust and reach past the speed of light. Because you're probably right, but you can do it by adding it up, and you can add it up over any length of time. See, each one of these M notations, M0, M1, M2, M25, that count my new 0 point of origins from the mother point, each one of those could be years apart between accelerations. So I can stretch it out over time, and I can add up my speed as much as I want to as I cross the universe over time. And the stresses on my vehicle only have to take the pressure from whatever my rocket acceleration is. They only have to take the pressure of X. I hope that I have finally explained that well enough for everyone to understand.